fourth order. Okay, so we can write the characteristic equation. Just replace this is lambda 4 minus 16 equal to 0. There is no third derivative or second or first. So this is very easy to factorize between two squares, and I factorize it. So I get two real roots here. See it? Lambda plus 2 and lambda minus 2. And here I get two complex. So your alpha equals 0, your beta equal 2. So it's very easy to write the general solution. It's case 1 and case 3, which is the complex, but non-repeated. And for the real and for the complex is very easy. So it's e2x, and here c1, c2, e minus 2x, and here cosine 2x because beta equal 2 and alpha 0. So there is no e alpha x. So this is the general solution here. Let's go for another exercise. Okay, I gave you a fourth order differential equation. This is number 2 here. Okay, number 2. See, all the terms here is there. Third derivative, second derivative, this one. And so I write the characteristic equation by replacing y fourth by lambda 4, third lambda cube. Here we can see it. Okay, so this is the characteristic equation. Very easy to put it from the differential equation. Now, to find the roots, we must little be careful here, because sometimes you can factorize, so it will be finished. So here, what I will do, I take the factors of the 4, which is there's no lambda in it, you take it, and I called it P to be the factors of 4, or divisors, the same. And S is the factors of the leading coefficient, which is 1 here. See? Here 1. The leading coefficient is lambda 4. So you take the factors of the constant, which is multiplied by it, and it's only 1. So the factors of 1. So be the factors of 4, and S is the factor. So I will list them now. Okay? Possible real roots will be P over S. So what you will do here, you take these. So this is what we need, in fact. So in this case, possible real root is the factors P over S. So the factors of 4, we know it from here, plus minus 1, plus minus 2, plus minus 4. Okay, and the factors of 1 will be plus minus 1 only. Suppose you have 3, it will be plus minus 1, plus minus 3. So this is the factor, you divide them. Okay, so I define the factors of 4, and P is the this is the definition of P, is the factors of 4. And the definition of S is the factors of 1. So P over S, possible real roots. This is what we need then. It will be P over S, and I will list them here. This is what I need to check now. So let's be careful in it. So when you start to check this is a root, you try the first one, which is very easy, plus or minus 1. So put lambda equal to 1 in your polynomial here. See? So P of 1, just replace lambda 4 by 1. Then here in this polynomial, it's very easy. You put lambda, insert lambda 1. So what will give you? Will give you this numbers. Here minus 2, minus 3, multiplied by lambda, and minus 8 equals. So it will have that. And this is give you 0 if you add them. So what's mean by that? Means that lambda 1 equal to 1 is a root. Okay? So it's a root. Okay, if it's not 0, it's not a root. You try the others. This is why I write here possible real roots. So we must be careful here what's mean by possible real root. Okay, this is plus minus 4, and I write here, this is the most important, how you try them. So it's very easy. You have 4. What's divisor of 4? Plus minus 1, plus minus 2, plus minus 4. And if you have 9, plus minus 1, plus minus 3, plus minus 9. Okay? Now, you divide by 1. What you do? You must be careful here a little bit. You put 1 here, and this is the coefficient of your polynomial. The coefficient of lambda 4 will be 1. The coefficient of lambda cube minus 2. then minus 3. So here this is coming from up all the coefficient of this polynomial. Now, what we shall do, you take the 1 down, okay? You take the 1 down, see? Multiply here by 1. This is that called it synthetic division. In fact, multiply this 1 here and put the result here. So you get 1 multiplied by 1, 1 multiplied by 1, you get 1, put it here. Add them. When you add this minus 2 plus 1, you get minus 1. Again, multiply minus 1 by 1. And you get it. This is the trick. So you put the result here. You add them. It will be minus 4. And then multiply minus 4 by 1, it will be minus 4. Add them. You add here. All you add here. So what you get 4, then you get the last one, you must get 0, because if not 0 means this is not a root. So you reduce now your polynomial from degree 4 to degree cube. Degree 3 it will be. This is the coefficient of this is degree 4, the polynomial. You take it from up. This will be degree 3. Now, again, what's the divisors of 4? Plus minus 1, plus minus 2, because this is the coefficient we needed here, the last one. So again, and what's the coefficient of 1? It will be plus 1. So I try again 1. Be careful. I try 1 again, and I get again 0. So it means that 1 is repeated root, see? It's a repeated root. We must be careful. Sometimes you try 1, then you miss 1 root also, again, maybe repeated. So what happened now? I take this one down, multiply here, put it here, and get 0. Again, add them, the same as we did before. And then 0 multiply by this one, the green one. It will be 0 here. Add them, it will be minus 4. Minus 4 multiply by 1, put it here. Add them, get 0. So again, when you get 0 means this is a root again. If you don't get 0 means it's not a root. Try other one. So this is now the coefficient of polynomial of degree 2. Okay? Now, we have 2 repeated root. So our polynomial now, ab, can be factorized to 2 repeated root, because we get lambda 1 and 1 here, up, you see here and here. So lambda minus 1 square will give you 2 repeated root 1. And now this is the coefficient here of the degree 2, because already we divide 2 times, so reduce to degree 2. So this is the coefficient of lambda square here. And there's no lambda, this is 0. And minus 4 is the coefficient of lambda to the power 0. So in fact, I factorize our polynomial, the up one, direct, very easy here. So you have the 2 roots here. Okay? And the 2 roots also real. You can factorize them. 2 and minus 2. In fact, what's mean by that? If you try these also, you will get them also 0. Because we get them here, you see? So, in fact, the 2 roots, it's 1 repeated, and plus 2 and minus 2. So, what's the general solution? We write it here now. So, this is the roots. I list them there. So, this is case 2, in fact, repeated root. And here, case 1. So, C1EX plus C2XEX, because of case repeated root, plus E2X here. And here E minus 4x. So this will complete. So be careful when you divide these things. It's not difficult. Just read it very well and you will get it. Now I take another exercise, number 6. It's a 6th order. See how it's I write it here. So this is the polynomial of 6th order. Of course, here there is no 5th derivative. So I replace it by 0. So there is no lambda 5. There is no lambda cube. There is no lambda, okay? Because the missing terms, be careful when you write the characteristic equation. So this is possible real root now, direct, P over S, because the factor of 81 plus minus 1 plus minus 3 plus minus 9, and you can go. But don't list all. And the factor of S, this is S here, and this is P. So P over S, possible real root, and I list them here. You don't need to list all. So please start with the smallest. It's easier for you. You need substitute in lambda. So let's just substitute 1 now. And as substituting 1 here again, okay, it will give us again 0. So it means 1 as a root. Okay, so I divide by 1. I take 1 down, multiply by 1, put it here, add here this line, the same as we did before. If you see, I put 1 down, multiply by 1, add them here, see, and it gave you 0. And again, if I try 1, I will not get 0. In fact, I try the second, minus 1, and I get again 0. See, so this is from 6 degree. This is 6th degree. This is 5th degree after. Now we get 4th degree of the polynomial. This is the roots here, now 1, and here the root, minus 1, so it will give you this one. See? What about this? Since there is many zeros here, so I thought it can be factorized. You see? So will be lambda 4 plus 0 lambda cube. There is no lambda cube, means plus 18 lambda square plus 0 lambda, there is no lambda, means plus 81. So this is it here. And this can be factorized to this one. See, it's very easy. If you try the other roots of the real, you will never get it. It's finished, because this gave you complex. This is why I said in the beginning, possible real root. So we have 2 real roots. Lambda 1 equal to 1, and lambda 2 equal minus 1. And here we have the complex, because when you factorize this, it will give you plus minus 3i. So alpha of 0 and beta equal 3. So I list them now. Here we have case 1 and case 3. Case 1 will give you e c1 ex, c2 e minus x, and case 3, it's the complex and repeated. See, repeated, m multiplicity 2, each root is repeated, so you have multiply by x, but 2 times only, very easy. Sine 3x, and it will be multiplied by x. So this is the solution for this equation. Okay, let's take another now, solving Euler equation. I already introduced Euler equation. This is a 3rd order Euler equation. As I tell you before, you need xet. So this is the substitution before I introduce it in the first video. So, and I write also x4 for you here, but we don't need it, in fact, because we have only 3rd order. So when we replace here x cube, so this will give you this one here, this one, x cube. So then 4x square y double prime will give you that term. And the 3xy prime, okay, it will be 3d, because here just this one, and plus 1, I take y as a factor. So this is our differential equation with d operator. This is the constant coefficient equation. As I said, you can write the polynomial p of lambda by replacing d by lambdas. Okay, and this is, you can factorize this is very easily to this one. Okay, and you get this is the first root, and the second will be 2 complex. So alpha equals 0 and beta equal to 1. So this is number 14, the exercise in the book. So we first write y of t. Be careful, because we are using exponential e to the power t. So this is y of t, e minus t. And this is gave you the complex, because beta of 1 and alpha of 0. Now you return back your x. This is the most important. Be careful, as I said. So from here you can get t ln x very easily. So this is the x minus 1 for that one term. So this is the second. Here I replace t by ln x. So in Euler, remember, there is no x here. It's ln x. So this is the sign. So this will finish this exercise. Let's go for another exercise, number 16. Again, 3rd order. We always in Euler we have x positive because of this. So we do the same here. We replace. So this is your polynomial again. Okay, I take a factor here, minus 6, so I get this term. So lambda minus 1 is a factor between the three terms here. Then you get lambda minus 2 when you take also minus 3 as, when you take 3 as a factor here. So it can be vector. It's very simple to this one. Sometimes you can factorize from the beginning, so you don't need to try possible real root. Possible real root when you couldn't factorize it. So this is the real roots, in fact, all real roots. So we write y of t first, as we did before. Euler is very easy equation, really. It's you can very easily derive the solution. Now again, x e t, so this is x, this is the fundamental set. See, when you have e a t will be x, e2t will be x squared from this. So this is your fundamental set, this fundamental set x squared, and x minus 3 for Euler. So this is y1, y2, y3. So it's very easy, as I said. Now, I'll give you another method to solve Euler equation. In fact, it's very useful, but be careful. So usually, if you go back here, you see x to the power. You see, this is x to the power. So x to the power lambda. Lambda 1, lambda 2, lambda 2. I called it in the second exercise r. So you start, there's no t here. Be careful, okay? So take the derivative. This is from calculus, very easy derivative. Powers r minus 1. So this is the third. And we solve the same exercise. In fact, here you said solve by using this. We must get the same result. So what happened? This is your differential equation. Take xr as a factor. When you substitute, you multiply here x cubed by this one. It will cancel, minus 3, and it will be xr as a factor between all the terms. So divide by it because x positive. This is your characteristic equation in this case, but I put it with r instead of lambda. And this is the same previously. It can be factor, the same, nothing in it. So we get the roots r1 equal 1, r2 equal 2, r3 equal minus 3. So since we are using y equal xr, be careful here. There is no t here, no t here. Be careful. So we have this one. Okay? So just x to the power 1, x to the power 2, x to the power minus 3, and this is the general solution. This is will finish chapter 4, in fact. And I hope I did everything for you here. And inshallah, we shall see you for chapter 5.